Okay, right, we have just done our first bit of river sampling. So we are at the moment, well, we were about 800 metres up from Skogar waterfall. So I'll show you in a second where we've just been, but it was chucking it down until literally about 2 minutes ago, so I couldn't get the iPad out to film it. But I have got some pictures to show you the river. So what we've done on this bit is we've literally just sampled the flow rate at 1.5 metre intervals as you go down the river. That was about all we could manage to do because it's a bit treacherous, it's really fast flowing, lots of big rocks, so just for general safety we're quite limited on what we can do. So what we did do, we marked out a transect, so every 150 centimetres we put in the flow meter and we sampled how fast the river was flowing. Obviously there is some things that we haven't been able to control as much as we wanted to, like for example how far in from the bank it was, just because it was difficult to measure, how far under the surface of the water we were, things like that. So it probably isn't as representative as it could be, but it gives you an idea of how difficult things can be sometimes out in the field to collect data. So I'll show you briefly, if I turn the camera around in a second, where we were out on the river as well. So right down the bottom in the background you can see the top of the waterfall. It is really windy, which is why the iPad is moving, but where that pile of rocks is, so where that person's just walking, that's down where we've just been sampling, so you can see how fast the river is flowing just down there. So it is quite tricky to try and get in, but while we're up here, our campsite is just over that hill and down the bottom. We have some lovely snow-covered mountains. We've got a lovely walk that goes all the way up into the hills, and you can walk towards the volcano that I'm not even going to try and pronounce. And we have a lovely group of people doing some biodiversity sampling.
Earlier we were at the top of this waterfall and now we're down at the bottom measuring the flow rate and the oxygen percentages. So this is a flow rate meter. What we've been doing is putting in the water at different intervals, both along the bank and going across the stream as far as my wellies will allow, to see what the flow rate is. Now unsurprisingly, the further we've got, the deeper it's got. We've had a much higher flow rate. But what's been a bit weird is the percentage of oxygen that's been in the water hasn't changed at all anywhere down this river, at the top or down here, which is not what we expected, because with that much aeration from the waterfall it should have got much higher further down.
So what about in terms of pH? What have we found compared to the glacier earlier?
Well, the pH is a lot less acidic along here. We've managed to find a pH of about 6-ish, whereas back at the glacier it was more of a pH of 4, which is surprisingly low.
What about in terms of nitrate content? We found nothing on the glacier earlier. Has it been any different down here or at the top of the waterfall?
No, absolutely no nitrates down here either, which, considering the plant life around, is slightly suspicious, to be honest, and a bit odd. I think it's something we might need to investigate further. It could be a problem with our method, it could be a problem with our equipment, or there might just be no nitrates down here.
Well, there's plants in the water, isn't there? So if we look, you can see plants in the water, so it is quite surprising we haven't got any nitrates. But in terms of what we've done, what have you found difficult to control? How would you, in a real world, improve the method?
Well, some of the differences we've had is obviously you can see that the path by the stream is... The banks are different heights, sizes, widths, it goes in, it goes out, it's difficult to measure the eddies. Really, we need to go from the deepest point of the river all the way down if we were going to do a fairer sample, or cross-section all the way across in some waders at different heights to get better information.
So what have we done so far? So have you picked a spot and just gone for it? Have you measured it?
What we've done is we've gone every 1.5 metres down, 5 I think it was, on the way down, and then we've gone every metre out as far as I could, which is about 3 metres going out, before it got a little bit too deep for my wellies.
Okay, thank you very much. So today we are at Glacier. Yesterday we were at Skogar. So as you can see behind Sarah, we have a stream which is basically geothermal runoff. So if we have a look up there is a geyser which keeps erupting, which I will do a video of later. And basically any excess water that's been heated up is running down, and it's running down to this. So Sarah's going to talk us through what we've just done, because we sampled the stream and roughly what we found. So
Okay, so starting at the top, where the water was coming out, we have sampled for pH as well as the width of the stream and the flow rate. Every metre and a half going down 10 times, that makes it 15 metres, to kind of see what's going on there. Now what's a bit weird is we found that it's alkali at every point we've sampled, which seems a bit odd. Flow rate does seem to depend on the width of the river. We haven't looked at all that data yet exactly.
So why are you surprised that it's alkaline? What would you expect it to be?
Well, normally you'd expect it to be acidic because it should have a lot of sulphur dissolved in the water, to be perfectly honest, and it doesn't seem to be showing that at all. And again, nitrates aren't showing, but then again that doesn't seem to be something that happens in volcanic areas.
Okay, so in terms of flow rate, if we have a look, so for example, if we compare where you are, so at this point it obviously gets quite narrow, so you would think the flow rate is going to be a little bit faster compared to, say, if I go back a bit to here. So it's a lot wider, so you think that it would be a lot slower here.
Hello, I'm Dr. Hill. I'm a teacher of biology from St Marylebone School in London.
And I'm Jeffrey, I teach biology as well.
Yesterday we were at Skogar, near the waterfall there, and we ascended up to a height of 120 metres, and we stopped every 25 metres and looked at the biodiversity to investigate how it changed as we went up the hill.
At each 25 metre we did 3 quadrats, and in the quadrats we measured the percentage cover of all the different things that we found there, and we picked our quadrats by throwing them.
Okay, so why did you pick that and not the random number method?
We threw them because we didn't have a big enough sample area to do the random number generator. Ideally we would do that, but it was hard
And it was quite steep.
and it was very steep.
Did you notice a change on the way up? Have you looked at the data yet?
We need to have a proper look, but we did find more species as we went up, but it seemed to kind of plateau off. We were still finding the same species at the top.
Okay. And river behind us, we've just been doing some sampling here as well. So what have you been doing here?
So here we have been collecting some algae samples. So we just scrape them off the rocks, and it's really hot water. The range is 80 degrees C to 40 degrees C. So we're going to see if they have different rates of photosynthesis to algae in the tank.
So is this something you're going to test at home rather than here, or are you going to do it here on the campsite?
We are going to test these here, and then we are going to do the same practice.
Oh, okay, nice. So how are you going to test the rate of photosynthesis here?
Yeah, sure. We are going to make some alginate balls from the algae, and then we are going to coat them in a solution of indicator. And as they are producing oxygen through photosynthesis, we are going to measure the change in pH of the indicator solution, and that will give us a measure of how fast they're photosynthesizing when we shine a light on them. And we're going to look at that rate of photosynthesis at a low, medium and high temperature, something much lower than 45 degrees and something maybe as high as 70 or 80.
How do you make the alginate balls?
We're going to use them, we're going to make them using an alginate solution, and we're going to drop that through a syringe. It drops into a solution of calcium chloride, and then the balls form, so it's really cool.
Oh, nice. We might have to come back to you later to see what's going on, if that's all right. Thank you very much.